Elimination is a very different strategy for doing exactly the same thing for solving a system of equations. Elimination is probably the most necessary and useful skill because it's used a lot more frequently in larger and more difficult systems, just due to it's a little bit simpler on the algebraic side. Now, technically, you can use substitution to solve harder systems. It is much more difficult, and generally we recommend elimination, which is why I'm going to focus more on it. But the idea behind elimination is very different. Instead of taking one equation and plugging it into the other, what we're going to do is we're going to add the equations together, or subtract them. You can technically do that as well, but typically we just use adding to. We're like, in my experience, students are much less likely to make mistakes when they're just adding them together. But the idea, like, why can we add them together? Before I actually do that, I wanted to say, well, why does that strategy make sense? Well, in a system, we have two very different equations. Like we have equation 1 and equation 2. Since they're equations, what that always obviously implies is that the left side must be equal to the right side. So those two things are equal. In the second equation, it's different, but those two different things are also must be equal. Now, if I were to take the entire left-hand side and add it to the entire right-hand side, I'm adding two things that are already equal, right? So if I take two things that are equal, I add two other things that are equal, that makes something new, but it's still equal. And the beauty of that is that we're creating a new equation, which is still true, which is like we're combining the two equations together using this original system, and it's not changing the relationship between x and y and so on. And the whole point behind elimination is that when we add those equations together, we want to make sure there's some sort of cancellation. Like in the case of this one, example number 1 from the packet, if I add them together, well, x plus 2x is 3x, y minus y would make 0, because right, 1 minus 1, 0, y is the same as 0. Or often, this is why we call it elimination, because we might say that those y's eliminate or cancel each other out. Also, the equal sign, you might wonder, well, what happens if I have an equals plus an equals? Well, we're not really adding the equal signs, because it's like we're adding the two left-hand sides together and the two right-hand sides. The equal sign stays the same because we're keeping the equality. That symbol in between is not changing. But anyways, then -1 plus 7 is 6. And what I'm left with is 3x equal to 6. And if I divide by 3, that would leave me with x is equal to 2. And notice how in some cases, elimination is very, very simple, very easy. And like algebraically, it's less work, right? When I was combining them together via substitution, took a lot more algebra to get the answer. And again, I'm not done, because in order to then solve for y, I need to plug it back in. And we can all plug it into either equation. I'll just use equation 1 when I'm back substituting. Another common practice with equations is to label them so that when you're using them later, because for a lot of times when we're doing math, we might understand what we're doing very well. But say, for example, we went back and looked at it a month later, or someone else was to look at our math. It might be, sometimes it's hard to follow what's going on when you have lots of different equations. And that's definitely true when you start dealing with systems of 3 or 4 or, other types of scenarios. So that, it's a good idea to label your work. Not necessary. You don't have to do that. But, not a bad idea. But anyways, we would be left with, when we back substitute in 2 here, we would get 2 plus y is equal to -1. And if I subtract 2 from both sides, what I would be left with is y is equal to -3. And again, I would get my answer to my system, again, by elimination. Now, sometimes if we're trying to apply the elimination strategy, again, step 1 is to, well, not necessarily step 1, but our main goal is to add the equations together with the goal that one of the variables will eliminate. You could either eliminate x or y, it doesn't matter. This one, we eliminated y because it was really easy, right? Right when I added them together, they canceled. Cool. But sometimes, and actually probably more often than not, when you look at your equations, if you add them together, 6x, -2y, there would not be an elimination. So basically we don't want to do elimination until it's ready to eliminate. So step 1 is to always get your system ready to eliminate if you're trying to use the elimination strategy. And how you want to do that, there's a couple, I mean, you could either get X or Y ready to eliminate. Let's actually just do both for the sake of practice. But basically you want to use the property of equality, the multiplication property of equality, to basically make the coefficients the same. 4 and 2 are obviously not the same, but let's just say I were to multiply through the second equation by 2. I'm always allowed to do that because if I multiply both sides by 2, it will remain equal. And if I multiply that by 2, notice the coefficients would match as 4. And then if I were to subtract them, they would eliminate. And what is more typical, technically you can multiply by positive 2 and then subtract the whole thing. But what I recommend is if you just multiply the entire equation by negative 2, that would get it, that would turn it into negative 4x, which when added to positive 4x would directly eliminate. And again, I suggest always having one positive, one negative, so that they will you can add and you don't have to worry about subtracting. Subtracting is always a little bit more annoying. But anyways, I'm going to keep the first equation the same. 4x minus 5y is equal to 16. And I'm going to multiply the second equation times negative 2. And I'm just going to write it kind of like this. I'm going to take that second equation, multiply by negative 2. And a reminder that when you multiply an equation by negative 2, every term has to be multiplied, not just one term from each side. So that would make negative 4x minus 6y is equal to 6. Each term will change signs and be multiplied by 2. Now it's ready to eliminate, right? Because when I add the left-hand side together, 4x minus 4x would make 0. And negative 5y plus negative 6y would make negative 11y. 16 plus 6 would be 24. Sorry, not 24, 22. That's much better because it's divisible by 11. And then I could divide by negative 11, solving for y, which is equal to minus 2. And you might wonder, are the answers always going to be pretty? And no, a lot of times in math class, we like to deal with simpler equations that have nice, pretty answers so that we don't have to deal with other types of numbers. But the answers could be fractions or decimals or whatever. You know, it just depends on the system. But I'd say most of the time when you're working on the homework, you can expect the answers to be pretty nice. But not necessarily. Again, it just comes with the territory. And then to finish solving for x, we would plug it back into either. I would probably choose number 2 for resubstituting it in, just because that equation looks slightly less irritating to me. Just the numbers are smaller, I guess. Doesn't really matter. Then I would have 2x minus 6 equal to minus 3. I could then add 6 to both sides, which would give me 3. So finally, I would have x is equal to 3/2 as my x-coordinate. And again, this might be a red flag, but it's not necessarily a red flag because fractions are very possible, as I was saying. And so that would give us a solutions 3/2 comma minus 2. And what I said is that you don't necessarily have to eliminate x, you could also eliminate y if you prefer. So let's just kind of check it. Let's see if we were to do it by eliminating y, would we get the same answer? And of course we would get the same answer because the solution doesn't depend on how I do it. It is just the generic answer. And however I do it, whether I graph it, whether I use substitution, whether I use elimination of x or y, all of those methods should come up with the same solution because it's just the right answer. And that's one thing that's nice and comforting about math sometimes, is that there is a definitive answer. It's not black and white, or it is black and white. Technically, there are a lot of mathematical situations where it's not black and white, usually when it comes to applied situations. But in algebra, there's a single answer a lot of the time. So let's try to eliminate y instead. So to do that, basically, instead of trying to match the coefficients on the x's, I would try to match the coefficients on the y. In this case, 5 and 3 have no common factors, so we would just want to multiply them by each other. If I multiply 5 by 3 and 3 by 5, that would make a match of 15. And since one is negative and one is positive already, I don't need to change the signs or multiply by any negatives, and that is always nice. So I'm going to take equation 1 and multiply that by 3. That would leave me with 12x minus 15y is equal to 48, right? I think that's 16 times 3, 32, yeah, 48. And I'm going to take equation 2 and multiply by 5. Again, the reason is if we multiply by the opposing coefficients there, it will give me the same number. And then I'll be ready to eliminate. So multiplying by 5 would give me 10x plus 15y is equal to negative 15. Then I'm going to add them together. So 12x plus 10x is 22x. 15y or minus 15y plus 15y eliminates. And then 48 minus 15 is going to be 33. Then dividing through by 22, 33 over 22 will reduce by 11, by a factor of 11, and that would leave me with 3 halves. As I said, as we know, it must be the same. So if we're getting different answers, we know somewhere we messed up. And that's, a way you could check, though, again, probably more work than is necessary. And of course, we should find the same y value if we were to back substitute. So in the next video, I want to talk about, well, what are the cases when we don't have a common answer, or when there's more than one answer, and we'll kind of summarize and really talk about every potential thing that you could face with a system of 2 equations.